Here we have unit 1C.4b. It's our second day talking about the completing the square. Today we're going to complete the square to produce vertex form. When we start with standard form, we're going to convert it to vertex form. To help us remember that what vertex form is, we have y equals a, x minus h squared plus k. That is our vertex form. Our actual vertex is going to be located at h comma k. So to start this out, we're going to set our problem up perhaps a little bit differently than we would in our first lesson with completing the square. We're going to pull this 22 off to the side. We won't necessarily subtract it to the other side. You could say y minus 22, or you could drop the y completely for now and bring it back magically later. Your choice. But from this point, we're going to need to come up with a c value that is going to make this a perfect square trinomial. So our b value is -10. So we're going to take our b divided by 2 and square it. That's our formula. So -10 divided by 2 and square it. We get the answer of -5. So when we square that, we get +25. So you would probably write it right in the blank area. But I want to show you that it's two different thoughts. You have the thought here where it's blank, and then you have the thought when you plug it back in. Now we're adding the 22 because all we did was push it off to the side to make room for our new c value. So we just push that over. Since we're not working on opposite sides of an equal sign, we're all on the same side of the equal sign, we're actually going to subtract 25 from both sides rather than add it because we're not on opposite sides of the equal sign. So why did we put in this plus 25? We did that so we could have a perfect square trinomial. This here, we created that on our own. We added the 25, but to keep the equation balanced, we also subtracted the 25. I wouldn't reduce those, eliminate those from each other, because we're going to use the 25 to create the x minus 5 quantity squared. Here, this is going to produce a 3. So now you can see that this is in vertex form, where we have our h and our k. The vertex is going to be 5 comma -3. So we took our standard form, ax squared plus bx plus c, and we converted it into vertex form. We pushed the 22 to the edge. We did our calculations of b divided by 2 and squared it. And then we collected our leftover like terms. That shows us what our vertex is going to be for this graph. With the next problem, we'll do the same thing. We're going to convert standard form into vertex form. So I'm going to push or pull this 95 off to the side. In previous problems, we've subtracted it to the opposite side. You could still do that. It would totally work. You just got to keep track of it. But because we're writing an equation, we're not solving for x, I'm suggesting you consider this. I don't need to write that one yet. All right. So our next step here is to consider what our c value is going to be. So we're going to take b divided by 2 and square it. Our b value is 18 divided by 2, which is 9 squared, which is 81. So our c value is going to be 81. So we add 81 so we can turn this into a perfect square trinomial. But we're also going to have to subtract 81 because it's on the same side of the equal sign. We have x plus 9 squared. Whatever's being squared here is the value that's going to go inside your parentheses. 9 times 9 makes 81, and 9 plus 9 makes 18. And then over here, we add up to be 14. So your vertex we get -9 because it's always the opposite of what's inside the parentheses, and we get 14. That's going to be our vertex here in vertex form. It would also be the vertex in standard form, and we could calculate that just like we had in the past. Our next problem. Notice how this one has an a value that's greater than 1. So that's going to make this problem a little bit different. Here, we'll do the same idea. We'll just pull the 7 off to the side. Now, we know from our previous lessons that we've got to be sure that the leading coefficient is 1 before we try to complete the square. So to make the leading coefficient of the x 1, we're going to factor out, because we don't want to lose it, we're going to factor out that 5. And when we do that, we now have an x squared plus 2x with our space for our c term plus the 7 that we've been bringing along the edge. So we say b divided by 2 and square it. Our b term is 2. Don't use the 10. You got to be sure to use the 2. 2 squared, or 2 divided by 2 squared, actually. So that's 1 squared, which is 1. So we have x squared plus 2x plus 1. I'm writing it on a different line to show you that it's a thought that comes after that process. And because we added the 1 here, we've got to concentrate about what value's really being included. Because the 1 is inside the parentheses and the 5 is on the outside of the parentheses, by putting a 1 here, we actually have 5 times 1. We have 5 times whatever that number is. Because it's a 1, 5 times 1 makes 5. So we're including a 5 by writing that number in there. So we have to be sure to subtract the 5. We can write our perfect square trinomial in factored form, and then we collect our like terms. And we see that our vertex is going to be the opposite of what's inside the parentheses and the number 2. Your h and the k for this vertex. We're going to move on to our last example. And you see that I threw in an example. If you would want to type in this crazy thing, you could also get it from the website and probably click right on it, or at least copy and paste it. But it will show you a step-by-step method online how to do it. But also what we're doing, we are trying to write this equation, which is going to be a circle. It has an x squared and it has a y squared. So this is totally different, but we're using the same method that we've learned before. R squared equals x minus h squared plus y minus k squared is the equation of a circle. So we're going to use this method of completing the square to convert what they give us into the standard form of a circle. So this format of a circle is actually something you might see on the SAT. So this question is very important, and that's why we bring it up in this lesson, because it's part of completing the square. You just have to do it twice. So we would want to organize our x values together. We have an x squared and we have an x. So keep those numbers near each other. Leave a space like we always do for the c term. Then you put in your y squared and your y term, and we will subtract the 65 to the opposite side of our equal sign. So our b term divided by 2 and squared is going to be 14 squared, or 14 divided by 2 squared, which is 7 squared, which is 49. So x squared plus 17x plus 49. And we have our y minus 10y. We have to figure out what its c value is going to be. So we're going to take our b divided by 2 and square it, which is 14. Oh, actually, be careful. Be sure you pull the right one. Negative 10 squared. Negative 10 divided by 2 and square it, which is negative 5 squared, which is 25. So we're adding our 25 here. Because our negative 65 was on the other side of the equal sign, we have to balance that by putting our 49 on that side and our 25 on that side of the equal sign. This here is now a perfect square trinomial. So we can factor that. We can write it as a binomial being squared. This is now a perfect square trinomial. It's whatever term is being squared. So y minus 5, quantity squared. And when we add these values together, we get negative 65, 49, and 25. That is 60 and 14, so 74. That's 9 away from this. So 9. So the center of your circle, your center is going to be at negative 7, positive 5, with a radius that's equal to 3.